Hello and welcome to this very quick demo showing frtb transformations on the bird data model. We're going to show in this demo some attribute lineage by following red lines in this diagram here, and then we're going to show data lineage because we've provided some test data and executed these transformations with Eclipse Freebird tools, and we'll show the data lineage and how we link the data items to each other. We'll follow the lineage. Here we're using an example with a cut down report of C91. Here's C91 frtb codec report. We're just focusing on these two cells and weighted delta sensitivities with net sensitivities per risk class, and then positive delta sensitivities. So only these two cells, both of them for the general interest rate risk class. So we'll see let's jump into it. We'll see the data lineage. Here's a cut down C91 report just with those two columns. There's a row that we'll see shortly. This is a C91 output layer. Excuse me. And this has the items that need to be filtered and aggregated to make the values for the report cells. Here in the middle we have net delta sensitivity slice. It's a slice, it's a part of the output layer. We build the output layer slice by slice, and we see it only has a subset of the attributes of the output layer because it focuses on a subset of requirements for the report, usually related to a small group of cells. And we'll see another slice shortly. Then we have the input items here. These are actually from the bird logical data model. So there's the security position entity, frtb risk measure for security positions, which provides a link to the security, frtb risk measure, which provides a link to the risk factor. Here we have general interest rate risk factor with the attributes required, and the delta sensitivities. Importantly, we also have netted delta sensitivities as what we call a derived entity. You might be familiar with derived attributes in bird. This is a concept of a derived entity. Now we can see the attribute lineage by clicking on these red items here. So let's start at the report. We see column 30 comes from sensitivities to delta risk factors on the output layer. That comes from sensitivity to delta risk factors on the slice, in this case the net delta sensitivities slice. That came from netted delta sensitivities in the netted delta sensitivities derived entity, and that came from unsurprisingly, delta sensitivities in the delta sensitivities entity. So that is attribute lineage. Now we'll show data lineage. We see here is a row 20 for interest rate risk. We'll see we have values of 1,000. Let's follow this first 1,000. How was it created? So it was created from these three numbers in the slice, 100, 500 and 400 added together. Let's have a look at that 500. Where did it come from? Well, it came from 500 in the net delta sensitivities slice. Where did that 500 come from? It came from 500 and the netted delta sensitivities derived. And importantly, where did that 500 came from? It was a sum of two values from data sensitivities entity, 100 and 400. A bit difficult to see, but if we look at side projection, we'll see that there was two items from delta sensitivities used to create one item in the derived netted sensitivities. The green rows show information related to a second slice, which is a positive delta sensitivity slice. Here we have a more one-to-one relationship because we're not doing any netting. A side projection shows interesting things. For example, as we highlighted before, we have a netting effect here, so we end-to-one relationship between delta sensitivities and a derived netted delta sensitivities, and the rest of the transformations are generally one-to-one. So we see one row from each slice is used to add to the output layer to build up the input layer slice by slice. And then we filter an aggregate on the output layer to create values in report cells. So that's data lineage. We see, if we look again at attribute lineage, one thing we've not included here is what we call entity to attribute lineage. So to make this slice, net delta sensitivity slice, we actually needed some other things. We needed attributes from entities to do a set of joins to link up the correct data. For example, we had to link the security position to the security to the measure using a security identifier link. So this is not shown, but if we were to show that, we would have full attribute lineage so that we can say for any cell what is the, we can calculate what is the ultimate subset of attributes from the input layer or logical data model required just for that cell, which is very useful for creating test data and doing ETL from banking systems in an incremental fashion. We also note something interesting. We have, for example, type of risk here. Oh no, so type and nature of risk. We default it here to sensitivity, so net sensitivity for the net sensitivity slice, and we default it to gross per risk class unweighted in the positive sensitivity slice. So this is not actually derived from anywhere. Similarly, subject to instruments subject to market risk as the main category is just defaulted. So that's quite a valid case to default items to something we want that are particular to the slice and the subset requirements that we are looking at in the slice. And again, we notice using the subset of items, we're not overcomplicating things by using different attributes that are not actually required for a particular requirement. So that's a brief overview of FRTB transformations on BERT. I hope you have enjoyed watching.